Our next step now is to configure the Flexisoft safety PLC. We're going to use it not as a safety PLC, but we're going to use it as just a logic controller, single channel logic controller. What we're going to do is we're going to take the outputs from the MLG that tell us the beams that were broken, the outputs Q1 through Q3 for the X and for the Y, and we're going to feed those in as physical inputs into our logic controller, and then we're going to write some logic in order to make sure that the X location and the Y location outputs are tied to a single bolt. So again, that'll give us our indication of bolt 1, bolt 2, bolt 3, or bolt 4. So let's get started now with the Flexisoft. So again, I'm going to go to SICK, Programs, Start Programs, SICK, and then here under Flexisoft Designer, we're going to click on the Flexisoft Designer. And again, you can download the Flexisoft Designer from our website, www.sick.com. And again, go to that software link and you'll see the Flexisoft Designer. Again, it's no charge. So when we open up the Flexisoft Designer software, you'll see here that it says first action. Our first action is actually we're going to connect to a physical device. So I've already connected my serial cable to my COM port, the other end of it to my CPU module. So now we're going to connect. And you see that when it connects, what it's actually going to do is it's going to bring in the configuration that I have there. So it's going to tell me what CPU module I have, what inputs and output modules I have, and it's going to do this all for you. You don't have to go through and set up the hardware configuration. This does it automatically for you. So you'll see that this is a very, very easy product to configure and set up. So again, right now it's creating the user interface and starting to build my physical hardware configuration that I have for this particular setup. Now it says, do you want to upload the configuration on the SICK CPU? We're going to say no here because we want to start from scratch. We want to set this up from scratch. If we said yes, what it would do is it would take the existing logic that's in there and would upload it into our project. So we're going to say no here because we can create this from scratch so you can see how it's done. And now by saying no, what it does is it actually gives me now my actual blank hardware configuration. So I have my CPU module, my input module, and my input-output module that I am physically going to wire to. So the next step now is to go offline and start to configure our actual system. So I went offline, and now I'm going to come down here to Elements. And what I want to do is I want to tell it that there are physical outputs from my MLG connected physically to these inputs on the Flexisoft. So what I'm going to select here is potential free contacts, and what they are is they're single channel, normally open. So when I click on that, you'll see it puts a normally open input here. Click it again, I'll put on the second one and on the third one. So these are the three outputs that come from my MLG x-axis. And now, since I wanted to do the wiring all across the top here, I did not use the rest of these, so I actually jumped over to this module here. So we're going to put now one more here. So that's now my Y output 1. And then we're going to click this, drag it over and put it here. Click it again, drag it over and put it here. So again, I have my three outputs on the X, and then my three outputs, which these come in as inputs from the Y. Now at the same time, what I want to do is I'm going to have four outputs here that I want to define, and the outputs will be for bolt 1, bolt 2, bolt 3, and bolt 4, since I have 4 bolts that we're doing our air proofing on. So I'm going to go down here and go to Output Types. Again, electrical symbols here. And what we're going to do is we're going to do PNP outputs. So when I click that, you'll see it puts an output here, and I'm going to do that 4 times. 1, 2, 3, and 4. So now I've defined my physical inputs and outputs for this project. Now that we defined the actual inputs and the actual outputs, now we want to assign labels to them so that we can actually use it in our logic editor. So to do that, we're going to come up here to the pie slice here, local IO, which is edit tag names. And you'll see here that this is the 4 inputs on the module that I defined. If I go to the second module, you'll see the additional 2 inputs and then the 4 outputs here. So again, the way I have these physically tied in, this is actually coming from the Y light grid, so it's Y output 1. The next one is the Y grid output number 2, the Y grid output number 3. And this is coming from the X grid, that output number 1. And then this is the X grid output number 2, X grid output number 3. Now, Q1 will be bolt 1 is selected, bolt 2, this will be bolt number 3, and this will be bolt number 4. So these are the 4 bolts right here. So again, when I write the logic will say that if the correct input condition exists, then it will turn on the appropriate output here. All right, the next step is now to actually write our logic for our error proofing project. So we're going to go to our logic editor, and you'll see here that it pulls up a blank page here. So now what we want to do is we want to actually create some logic here. So what we're going to do is we're going to first say that we're going to do our bolt 1 configuration. And our bolt number 1, we know that bolt 1 is selected if the Y output 2 and the X output 3 are actually active. So we're going to pull here the Y output number 2. So I'm going to expand both of these. So Y output number 2, and put this on our grid. And then we're going to do the X output number 3. So come here and get the X output number 3 and put that on my grid here. And now we're going to go to the function block and we're going to AND those together. So we're going to say that if this output and this output are on, then we know that we're actually in the position of bolt number 1, and we're going to turn on bolt number 1. So now with my mouse here, I'm going to connect these together. Okay. And now I'm going to click to my outputs down here, and again, click on my module, and we're going to say bolt number 1 has been selected. Again, we're going to connect these lines together. So if this input is true and that input's true, then we know that we're physically on the bolt 1 position. Now I'm going to do one more, and then I think you'll get the idea of it. Now we're going to configure bolt number 2. And we know that bolt number 2 is selected when the X output 1 and the Y output 1. So when X grid output 1 is high and Y grid output 1 is high. So in this case, we're going to be X1 and Y1. Again, we're going to say the AND function here. So grab it, drop it over, connect the lines. Go to my output, and now we're going to say bolt number 2. You can see if I actually take this and just drag it right across that, it'll actually create the line for me. Okay, so we're going to do this all the way through bolt number 2. All right, so what I've done is now I've gone through and I configured the remainder of these. So you could see we have bolt 1, bolt 2, bolt 3, bolt 4. These are our input conditions for each one of these. So you'll see as we put this together, you get the actual logic. So if the light grid, Y out, X out 3, we know bolt 1 selected, X out 1, Y out, Y output 2 for this one, and X out 2, X out 1. If that's active, then again, bolt number 2 selected, etc. So what we've done now is we've wrote the logic now to turn on an output to error-proof our application. So when the torque wrench is on bolt 1, we know that output goes high. When it's on 2, that goes high. When that's on 3, it goes high. And when it's on bolt 4, the 4 goes high as well. So now that we would have this set up, we would now go online. We would now connect. And once it's connected, we're now going to transfer this program directly to our logic controller. Okay, so we click that. So we're now transferring it to our logic controller. And we are online. So now what I'm going to do is I'm going to take my physical torque wrench here, and I'm going to put it on bolt number 1. You can see when I put it on bolt number 1, those two inputs from the light grids feed into here. It makes that condition true, and then my bolt number 1 output turns on. Go to bolt number 2. Again, you see bolt number 2. I'll go to bolt number 3. Bolt number 3 turns on, and I go to bolt number 4, and bolt number 4 turns on. So there you have it. Error proofing using the MLG light grids and also using the safety logic, the Flexisoft, to do a little bit of logic so that we can actually error proof the application.